serve as, I mean, Zoom takes your attendance, right? But that serves too as your attendance for staying in the class with me. And I will give points, or like if you are on the cusp of a C or a B or a B or an A at the end of the semester and you were in every class and I know that and you answered all these questions, like, and had, which hopefully it's kind of fun. Um, then I will consider that. But if you're never in class and you say, "Oh, I'm so close to an A or a B," like, you can't give me 1 point. It's like, well, no, because you weren't here, and this is virtual, so it's kind of nice for all of us because we literally can do this from wherever, right? And then Alice says, "Sorry, eating popcorn." I also don't mind if you're eating. I took a class online. I was in a boot camp and recently, and I was constantly eating. It was a night class. We were all working full time. Like, it was required. You had to have camera on, and I was eating dinner every single week. So if you were eating, I mean, if you could share, that would be nice. But right, we're not close. So yeah. So I don't mind that at all. So eat your popcorn. Now, these, in terms of, I think, in terms of our lectures, so Joseph asked a question, are they recorded? I am not going to record and post these lectures. What I will do is post the notes. I'm going to be sharing, assuming all goes well, I'm going to be sharing my iPad and writing notes down for you, and I will post those to Blackboard when they're finished. So your notes will be in Blackboard, and I'm actually going to go through that now, but you will not be able to watch back recordings of our course. It's because this course specifically, per the university, it's I think they call it synchronous, because it means you have to be in attendance live in order to get the virtual class experience. Granted, if you have to miss, in the syllabus it says there's, like, you can miss, up to however many, 3 classes or something, without me having to withdraw you or without really having any major issues. And especially, obviously, if you get sick, like, you just need to be in touch with me. But I wouldn't worry too much about it. So give me maybe a few minutes. And I know one person already said they were like driving home and might be a few minutes late. So just give me a few minutes to try to fix my iPad issue. And I'm pretty sure I joined here twice, so it's going to look weird if you see that. But I don't know if anyone else, I've never had issues with an iPad, but this is one specifically from Austin Community College, so it's not mine. So I'm just, what's wrong with it? Okay, so Tristan, yeah, Joseph, if you want to record the classes, I mean, I'm not stopping you, but I'd say per the university, you didn't tell me this, or you're not doing this, I think. Okay. But I don't mind. And what's wrong with it? Okay, so first, my iPad wasn't letting me log in to Zoom, which was a huge issue, and I also couldn't connect it to Bluetooth to my personal computer, which is what I'm using for Zoom. So these were 2 things where I couldn't connect, but now I'm in Zoom, and I'm pretty sure I can share my screen. But yeah. So I'm pretty sure we might be good now. So I'll kind of keep this. Actually, yeah. So I will try to share that in just a moment after I go over Blackboard with you. But thanks, Joseph and Tristan. Maybe Tristan, if you're the tech guy, if we ever have issues, I'll go to you. Okay. So just to start, I'm going to go over Blackboard a little bit and show you guys for this course, kind of what's going on there. Maybe I'll tell you a little about myself. And then I have this first assignment for you guys. I think I made it due Thursday night or something. But it's not really math related. It's more so me getting to know you and all of us getting to know Blackboard and making sure we can submit assignments. So let me, oh gosh, okay. And if ever I like think I'm sharing my screen and I'm not, just, yell. Like, you could call me Kelly, Professor Maluccio, whatever you want to say, but just say, hey, we can't see. Okay, so hopefully you can see my screen here now. And so this is when you click on the course, pre-calculus hopefully you are all here for pre-calculus functions and graphs, right? When you click on this course, uh, you should be able to see announcements. Again, mine will look different than yours because some of this is blocked off right now. I tried to make it really easy for you guys to understand, and hopefully it's clear. So I just made this announcement last week, or what? Okay, Monday, August 8th, because I had the syllabus ready and I was like, I'll post it to Blackboard. I don't even know if you could get in. Um, and I'll put any other announcements, I'll put them here, but I haven't used announcements a lot before. In terms of attendance, oh shoot, I think this will go to quickly maybe. But I am going to do like normally, okay, so normally, I don't know if you've experienced this, but you get a code. I'm actually, after every class, I'm not going to do the code, maybe because I'm lazy, or also I don't know, for some reason it's probably easier for you, but maybe not. I'm just going to go in and manually do it after every class because I'm going to let Zoom take my attendance. Oh, let me move this. And I'm going to just after every class go in. I'll see who answered the question. I'll also see who was in attendance in Zoom. We can see like how long you were in class for and all that. And then I'm going to put attendance in based on that after every evening. Just because I think for me, it'll help me also just get to know your names because I'll see your names over and over, even if I'm not seeing your faces. But yeah, that's the plan. Uh, when I am I'm moving in like a month. So when I am there, I might even have a better setup and another monitor and be able to actually like have your faces in one area, my computer here, the iPad. So we'll see. But for now, it's a little sad of a setup. So you won't see the course evaluation yet, right? But the course info, so you can see syllabus and you can click here. If you click on this, it's a PDF, I think. If you can't view it, let me know, but it's a PDF of the syllabus. It goes through really everything. And I want you guys to just read it over the next, if you haven't yet, over the next few days or this week, because I think like the add drop period is this first week. So if you decide like, okay, this isn't for me or whatever the case, just check out the syllabus. And if you have questions, let me know. But I'm not going to bore you by like going through every page. But if there are questions, please, please, please email me. And my email is on there, or ask in class. Okay. Then you can see textbook and course materials. Now, there's a lot going on here, but we will be using ALEKS, right? If you don't already know. So to access it, you can click this link. Here's instructions for how to register. I even needed this because I have never used it as an instructor, or once, but like 8 years ago. So it was a long time. The class code is right here. So you can copy this once you register in ALEKS, and you should be able to view all of the class information and the assignments. This is a link for the textbook. That was instructions for me to how to log into ALEKS. And then this is for you. I'm pretty sure you can see this too. Just information about ALEKS and how to get in here, and what, the information about the course and all of this, right? So this is a good resource for you guys. Zoom links. So if you didn't figure this out already, you can join class here. You can join office hours here. I will have office hours from 5 to 6 prior to class on Tuesdays and Thursdays. If I'm not seeing a lot of people coming, I may only do 1 day a week. But if a lot of people are joining, I'll keep it to 2. And you can always email me if you want to set up a separate, time or anything like that. Then lecture notes and reviews. So I've already, again, hidden from students, you can see this, but I've posted the Unit 1 notes, and it's a really large PDF. So what I recommend you do, if you want sections broken up, let me know and I will post those. But I thought it would be easier to post the whole notes for each unit, and we'll have 4 tests. These are the 4 units, right? You'll see them once we start. And you can either print the PDF and then write notes while we're in class, or if you have an iPad or a tablet, if you're fortunate enough and you like that, you could pull up the PDF there and write notes while we're in class there. But that's what I would recommend you do, either of those things. Granted, I will, when we go here, there's nothing there now. So, but once I start writing notes, I will put my written notes in here, and you guys will have access to that after class once it's done. So if you're not taking good notes or if you miss something, you can look here. But again, to be successful in the class and like really understand, I think it is best if you are writing the notes yourself. In addition to, you know, viewing my notes and I really can't promise my handwriting is any good on an iPad. I'm doing my best, but on a board, it's in person, it's a little better. So gradebook, obviously that's self-explanatory there. And then your assignments here. So if you click Alex, I think this goes straight to Alex and this will go to my Alex. So I'll let you guys do that. But then I have documents here. This is just how to scan and submit when we have quizzes or tests, right? Because exams are going to be proctored, but they will be virtual. So I will be sending you the exam. You will have to either write your answers on a piece of paper and scan it, or again, if you have a tablet, you can download the exam and write on your tablet. But this is like major like honor code and all of that. I mean, being virtual, you know, but it's also timed, right? Because so it's not like you can be looking up all these answers and I don't know, in that amount of time, but we'll in class, like the exams will be proctored that way. And these, if you're not tech savvy, unlike who was it, Tristan or something that was, if you're not tech savvy, these will help you figure out how to submit things. And then submitting work to the scanner. I've read this last semester. My students all used it. I still struggle with it, but they all got it to work. So if you want to scan written work, this is what to do. If you want to attach files, here's some things you can do. So there's, you know, these are very intense directions if you need help. If you know how to do it, you could just go to submit assignments here. And this is our first, you know, I'll post quizzes and exams here. And this is our first kind of trial assignment. I think it's available to you, right? And it is going to be graded, but it's just some first day questions that I'll put up on the screen. If you want to screenshot them later, I'll put them on the screen. It's just some information about yourself. So this is where you'll do it. You'll click on it. You'll submit a PDF or scan your document or however you want to do it. And hopefully that's accessible for everyone. These last ones, tools and online tutoring, they're just kind of links that are in every course. So there is online tutoring available through ACC. They have a lot of different tutoring options if you're interested. Okay, so that's Blackboard. Before I move on, are there any Blackboard questions? Or are we feeling okay? And sorry, I don't have the chat up, so if that's going, I'm out of it. Oh, Tristan asked how old the iPad was a while ago. Sorry. I really have no idea. ACC just gave it to me and said, here, you can use this. Because I don't have a tablet to write on because I don't know, a teacher. Okay. So if there's no Blackboard questions and that's all pretty clear, that's great. Let me go to your first assignment. Again, we're hitting some non-math things for a while, but we will get to some math today. I'm sorry if that disappoints, right? But let me attempt to share my iPad now. Oof, moment of truth here. How the heck? Okay, share content. I don't know. Oh, no. I feel like my mother or something. I sound so old. Everyone on your screen will be recorded. Oh, the iPad is recording. I don't know why, but maybe because it's ACC's. So it does say it's recording. I don't know how I'll get access to it, but that's great. Okay, so let's figure out. First, I have these. These are just, I just typed this up because this is what I'll want you to submit in Blackboard, right? So there's just these five things. And feel free to write something else, but make sure you submit it in Blackboard in that like your first assignment thing. So you'll put your name or your preferred name, nickname, your career goal or your major. So some of you, might just be taking some courses at ACC for something. Some of you might have just got out of high school and you're starting at ACC. So I'm just curious, like where you're all at, what you're trying to do. A fun fact about you, so it could be hobbies, interests, something like this. Where did you grow up, or where are you from? I know these might be two different things, but just like where did you spend maybe most of your time? I know a lot of people maybe are Texas locals, but I'm just curious. And then how do you feel about math? So do you like it? Do you dislike it? Do you love it? I just want to get a little feel. Um, and if you have questions about this, I mean, feel free to ask or type in the chat. Okay, Alice says, I'm sorry, I just see this. Can you briefly go back through the taking tests? Do we get it from Blackboard? Yeah, so when you take the tests, you'll join class just like you did now. I'll post it in Blackboard, and then you will view it. You'll have the whole class period to take it. You will need your cameras on for this. So if you do, make sure those days that we have exams, you can turn your camera on and show me your screen or show me your area so that I can see you working. And then when you're done, you'll message me in the chat, and like we'll go through this process, and you'll scan it and submit it in Blackboard. So it will all be Blackboard. Hopefully, Alice, that answered your question. And Adrian, this is the first day info. Sorry, it's a bit unorganized. But this is maybe this is. Let's see if this right.
So just to expand on that test question, or that test question. So the tests aren't going to be done in ALEKS. Is that correct?
Oh, the tests are not done in ALEKS. That is correct. Yeah.
I think that's good. It's
the
kind of unforgiving.
Yeah, no, ALEKS, your homework, all of your homework is in ALEKS, and that is all.
Awesome.
Yeah. Good question though. But I do have to say something else about ALEKS, and I'll get to it. I know there's a lot of information. My pen isn't working right now, which is really, really frustrating. So I'm wondering what I can do about this. Let me plug it in for a second. Give me a moment. Well, and of course they gave me a Logipen. I don't know. So it's not it doesn't really go with, let me check my settings. Sorry, I just moved from the screen if you were paying attention, but where are settings? Bluetooth. I think I have Apple Pencil. Oh, here we go. Okay, that's why it wasn't working. All right, I'm sort of tech savvy. Let's see if this works now. But okay, so yeah, this is going to be that first day info assignment. Hopefully you've had enough time, and let me go through it maybe with myself, just in case you were wondering. So my name is Kelly Maluccio. I'll be, your pre-calculus professor this semester. I guess I won't, my career goal, I wanted to teach college math. So, but I actually started out after my undergrad. I taught high school for 5 years, high school math. And then I went back to grad school, and I was a TA at Texas A&M for 3 years. I was teaching engineering calculus there. And then I started teaching at ACC when I left there. So I also teach a class at St. Edward's, which is fun. We'll see. It's my first semester there, but I've been at ACC for multiple semesters. And then maybe a fun fact is I really like food. So if you're all in Austin, because this is virtual, but you're at Austin Community College, so I'm assuming or hoping maybe you're all in Austin. I love it here, and I've been here for about 5 years. And if you have any food recommendations, I'm always down to take that. And then I grew up in the Northeast, all along the East Coast. If you can tell, I don't think I have an accent, but everybody always tells me I do. So maybe that's true. But I grew up mostly in Connecticut, and then spent time in Maryland, Pennsylvania, around there. And I clearly, well, maybe not clearly, but I love math. And if I get a little too passionate and go too fast and get excited and something is unclear, please just stop me. The course, I don't know, I've never taught pre-calculus at ACC. I have taught it I taught it at a few different high schools, but I don't know how the pacing is going to be, and I will just do my best to set you guys up for success. Okay, so that's a little bit about me. Let me grab my pen and let's see if I can get this to write now, and I will pull up the notes. Oh, another fun thing, I guess, is I love animals too. I mean, I have 2 dogs. So if you do have animals that come in and out of the screen, I also don't mind that. If you're eating or I see your animals, you know, these are fine things. You're going to hear my dogs bark probably more than you'd like, and they're annoying. So let's see.
What kind of dogs are they?
I have Aussie Doodles. And they're brothers, but okay, I don't know what happened, but I was gonna. Why is this there? Oh, okay. All right, give me a sec. Sorry, this is the first day. Just for those of you, that question I answered before, but maybe this will help. Yeah, they're brothers, but they're a year apart. So one is 6 months, so puppy, and the other is about a year and a half. So they're a lot of energy.
They don't shed, do they?
No, that's what's really nice about them. Yeah, it's very nice. However, when they get dirty and muddy, it's not great. All right, let's see. Miranda has a kitten. Oh, Panini, that's pretty cute. Oh, wow. Okay. All right. We got lots of cats. Yeah, that's so fun. Yeah, I met a dog once named Omelet. And at first I was like, that's a weird name, but then it grew on me. And I was like, wow, I should have named my dog Omelet. That's so cute. But okay, anyways. So everyone good, or any disputes if I move on from the first day info? Oh, Benji. Oh, yeah, that's cute, but the shedding. All right, no disputes. I'm moving on. Oh.
If that assignment there is not downloadable.
Oh, this? Yeah, sorry. Okay, so I did not
themselves.
put this anywhere. I was kind of last minute throwing this together, so I did not make a document. So if you want to screenshot this right now,
These are the students.
I would,
That's
if
the
you
teacher.
can on your computer, screenshot it, save it for later, and just answer these
Thursday, I have a cat
questions
named
and
Dev.
submit that. Yeah, I'm sorry about that, Michael. Thank you.
Sure.
Wow, 4 chihuahuas. That's a lot of energy too, but that's cool. Oh, and a gecko. That's wow. We've got all types of pets here. This is good.
Put the boy eye.
Cat named Jeff. Yeah. Okay. I'll give everyone another moment to take a screenshot of this. One of
Sorry,
my
what?
dog's favorite dog friends. His name is Jim, which is kind of funny because it's very
You can wear
human,
mine.
kind of like Jeff, right? But okay.
I feel like I just like a
Um,
No, you
And if so, like I said on Blackboard, if you want to write from the notes for today, I know maybe it's too late to print them if you would have printed them, but if you want to write on the notes for today, go to Blackboard and go to the lecture notes, like reviews, and you should be able to download Unit 1. Granted, it's very long because it's like 20 or 30 pages, but we're only going to go over the first like 4 pages today or so. So, because we're just going to do one section at a time. And if you want, I'm going to now go, so this is the notes for today. So, okay, maybe it's like 4 pages, but if you want these separately and you want, if people prefer not one big file, because maybe it's hard to open, I just genuinely don't know. But if that is the case, I can upload each of these individually in Blackboard and say 5.1, 5.2, 5, and I can do that. And you can write from there. So please just let me know. I just really don't have any clue what is going to work best. And so I was just trying to make it like, I thought, one document is going to be easier for all of you guys. But I'm not sure.
Well, we go through chapter 5, then we go to chapter 3. Is that a separate document, chapter 3?
No, it's still the same document. So we kind of skip around, right? The first unit, so I'm gonna call them each units, like one, two, three, and four. And they kind of go in order, but they kind of bounce around too. And the reason for this is because whoever put together kind of our course, they decided that, and when the textbook was written, I guess we've changed our minds. They decided that these sections go better together, and we'll see if that's true or not, right? But I think that's why. So it should make sense, and it's all going to be in one. Like, so if you scroll down in yours, like mine ends. Oh shoot, mine ends at 5.1, but you'll see 3, 5, and 6 at the end. Yeah. Yeah. Thanks, Michael. Okay. And wow, lots of people have dogs. So, okay, Michelle did say it'd be easier if they would be split up. So Michelle, I can do that tonight after class. And so for now, for tonight, you'll have this long one, but after class, I can do that and have it be split up for you guys, because I apologize. I didn't know. If that is easier, then that's what I'll do. I'll leave them both, because if people like the big bundle, that's fine. Let me just say one more thing before I start on the real math here, right? So this is pre-calculus, right? And you need to, in order for ACC, you have to have like a prerequisite, that's cleared through the university or through ACC. And this could mean like an unofficial transcript from another institution, or or like a placement score or something like that. So for those of you that are done with this, you can ignore me. The notes will be posted online as well with my written in. Yeah. For who asked that, Miranda. Yeah. But what I want to say is there are maybe 10 of you that have not completed this prerequisite or whatever that ACC requires in order for you to take this class. You have until Friday, August 26th. You have until end of day Friday to do this. But if you have not done it, there's 2 things you need to do, and you either maybe I'll write it here. So prereq. You'll email this woman, Lindsay Orlando. I'll put her email in just a second. You'll email her your ACC ID, your name of the instructor, so that's me, and evidence of your I forgot I put something here. And evidence of prereq. So again, this could be an unofficial transcript. It could be a score that you got on some placement test. If you don't have this, then you can go in ALEX. You can go in ALEX and you can take the ALEX placement for higher level math, and you just have to earn a qualifying score before Friday, and they'll count it. So and Colby, I think you just asked something. So you took a placement test at ACC. Was that the TSI? Is that what you took? Do you know?
It was the Alex placement.
Oh, the Alex placement. Okay. Oh, so did you do that like this week or?
I did it last summer.
Oh,
this past summer.
Okay, because these are the people that in ACC's system are not cleared, and Colby, you are one of them. So I'll tell you what maybe you should do about that, because maybe they just didn't update your Alex. But so I have Michaela, you're one of them, Joel, Franco, and if you're here, I guess hopefully you hear me, but I'll say it again on Thursday. So we have Michaela, Joel, William Jefferson, Colby Johnson, Paul Lim, Kriti, Samuel, Peyton, McKenna, and Bertha. So if I said your name just now, And Paul said you took it a few weeks ago. Okay, so I checked this yesterday. So either it has not updated in the system, or and is there an IA for this course? I I don't know what an IA is, so probably not. Um, uh, and you've taken the places. Yeah. So what I would do, if we are not on this list, if you're not on the list, if I didn't say your name, you're good. You can be in this class. Those of you that I did say your name, if it does not update in the system and you are not cleared, or I don't get an email from this woman by well after Friday, this means that you will be withdrawn from the course. So you just want to make sure, if you really like, have the prerequisites. So Lindsay's email is this. Well, it's just L Orlando. I mean, at Austin. So L Orlando at austincc.edu. Right. That's her email. That's an L. I'm sorry if that's hard to read, but so just email her, and again, email her your ACC ID. Tell her you have me. You can say Kelly Malucho. You can just copy my name from the course. And then actually, and I'll type this in the chat. Maybe that'd be easier too. So ACC ID. Yeah, and thank you, Joseph. That's her email. My name, and then evidence of prereq, or ask, or for those of you that have taken the Alex placement. So that was Colby and somebody else who just said Michelle or Paul. So for you two, I would just tell her, like, explain the situation and say you took the Alex prereq, but it hasn't uploaded or updated in my end. And I'll check again on Friday, and maybe it just takes time, or maybe they need to do something, but please just be aware of that. Yeah. And I don't want any of you to get like pulled out of the course for no reason. Right. And for somebody did just ask, does math TSI count? So the TSI, it is part of it, but it's not. You still have to have the other prereq. So everybody in here, actually, except for one person, it said had TSI, was all set. But if there's an issue there with that, I think that one person, if they get the other prereq, then the TSI comes as well. But so for those of you asking about the TSI, yeah, you all do have that, but you also need the course prerequisite.
Hello?
Yeah, hi.
Hi, my name is David. Do I just like speak like into the microphone?
Yeah, I hear you.
Okay.
Your name, you're all set though. I did not call your name, so you're cleared for the prerequisites.
Awesome, thank you.
Yeah, no problem. Yeah, if anyone else is unsure, feel free to speak up or type me in the chat. You can privately message me too. A fellow David. All right, there's two Davids. Sorry. So that was my bad. Was there another David I said, or no, we just have two Davids in here and both of you are good. Okay, cool. Three. Oh, geez. Okay. All right. So yeah, hopefully I've answered everyone's questions on that, but and I'll remind you Thursday, but just make sure you contact Lindsay about this, Lindsay Orlando, and she should take care of it. Or tell you what to do, right, in order to take care of it. Okay, now we're gonna get into some weird math stuff, and I say weird just because a lot of this section follows a cockroach, and that to me is so Texas and also disgusting. So if you're not a bug person, think of it as a butterfly, or I don't know, something nicer, a sticker. It's just a sticker. I don't know. Okay, so let me. I don't really know what I'm gonna do with this little, but like this guy is just separate. But okay, I'll leave it there. Let me make sure. Oh, and at the end of class today, I will ask just like a short question, and you'll type the answer in the chat. And again, I mean, it will be attendance, but it'll start the fun, hopefully. And if you have any questions that you think, like some days, I mean, an example is like it could be something personal about you, like, oh, do you have a pet? You know, we've already kind of gotten into that. But it might also be like chocolate or vanilla or sweet or salty, you know, like something like that. And you just have to answer one word, right? Oh yeah, which pages do we need to print? So if Michelle, if you're going to print right now, it's just the first 4 pages of Unit 1. It does, but Miranda's correct. You can print all of it that I've posted. It's just one. It's literally all the notes for Unit 1. So if you print the whole Unit 1, which is like whatever 25 pages, you'll have everything. Maybe I suggest double-sided if you're printing, just to save paper, but up to you. Okay. So now I'll get to it. And I apologize if I'm not up on the chat. So if you're privately messaging me and I miss it, I'll try to check often. But if you're messaging the group, feel free to, like, even if someone else sees a message, unmute. Because if I'm looking at my iPad and not my computer, you know, I'm not tech savvy. So we're doing our best here. Okay. So here's the roach on a fan problem. We're starting, this is our, for some reason, the cockroach is our motivation today, which I'm not like super happy about, but we're just going to deal with it, right? So this cockroach, it's our motivation of the day. And we're going to be talking about it going around, like the fan is moving around, right? So the cockroach is moving with the fan. Again, if you prefer a butterfly or something nice, think of that, right? And we're going to use this to talk about angles and like what angle it's facing or different things like that. So this first problem, draw the angle in standard position. So this is 245 degrees. So we always start, like if we're looking at this type of thing, we always start on the, like, if you think of a graph, like the x-axis, we always start on this positive x-axis. And our angles here are 0 degrees, that's the beginning, 90 degrees, 180 degrees, 270 degrees, and then, I mean, it goes all the way full circle, 360. So if you think of this fan, right, he's starting at 0, like this, and then if we go all the way around, one full circle would be 360 degrees, right? And then there's this terminology over here that's just, you know, terminal side, the vertex, the initial side, and the angle here. This is just some terminology of the angle. I don't know that we even talk about it much later, but there might be like a word problem that says, oh, you know, what's the initial side, what's the terminal side, something like that. Okay, so let's. Oh, sorry. I lost Zoom for a second, and I want to make sure. Again, it might be best for you guys to unmute if there's something to discuss or you can't read something. Okay. Now, what I want to note is that if we want 245 degrees, we know that's between 180 and 270. And so that's going to be, you know, maybe somewhere like from 270, let's say 65, 60, 55, 60, 45. Let's say it's like, I mean, okay, that's not perfect, but as long as it's somewhere in between here, let's say this is 245 degrees, and it would be this whole thing here, right? And another thing just to note that I think when you're looking at the ALEKS assignment, like these increments in ALEKS, each like tick mark is, I think it represents like 5 degrees. So just keep that in mind. Mine, well, I was trying to do 5, but like there would be way more in here if that was the case. But yeah, so just keep that in mind when you're solving these problems, because I think there's a homework assignment. Your first homework assignment might have some things like that. Okay. And we can see like this, the initial side was the side that I had started with here, right? And the terminal side is the side that I drew. And the vertex, well, here technically, I mean, the vertex is just going to be in the middle for us. Okay, now we want to look at negative 60 degrees. So let's maybe do this. So negative 60 degrees is going to be, so now we want to go negative. So negative, you still start at 0. You still start at 0, but this is negative 90. We go reverse we go reverse clockwise. No, clockwise? Yeah, clockwise is negative. counterclockwise is positive. Man, it gets confusing, but it's not confusing. Okay, so if we're going to be negative here, I know that negative 60 has to be between negative 90 and 0, right? So again, our initial side is right here, this yellow that I'm drawing, and then we go negative 60, so it's like almost to 90, like a 2/3 of the way, I don't know, somewhere maybe like here. And this would be negative 60 degrees, right? And we go down from the x-axis instead of up. And this is just kind of some basic angle measures. So the way that I drew the cockroach, it was going in the positive direction, the way that I drew that circle. Okay, so now we're going to look at kind of, well, this is weird to me, this minutes seconds thing, but we'll bear with it, and you'll mostly just see radians and degrees after a certain point. But for some reason, I don't know if it's like this course, this textbook, or what, it has like 1 degree is 60 minutes, or 1 minute is 1/60 degrees. And then it has like, okay, 1 minute is 60 seconds. We all know that. But so 1 degree is 3,600 seconds. And then it has the same thing, you know, for the seconds in minutes, or over here, right? So just things to note here, and what we write, for whatever reason, when we write a degree, we write like 1, or when we write a minute, sorry, we write 1 with an apostrophe. It's kind of, it reminds me of like feet and inches. So if you know like feet and inches, like usually if you write like, well, I'm a pathetic 5'1", so you know, it would be 5 with 1 dash and then 1 with the 2 dashes. But so this will mean, so like 1 dash is going to mean minute, but then, or not dash, apostrophe, right? And 2 will mean seconds. So like 1 second would be 1, 2, there. Okay. So now the only reason this whole chart is here is just to help us for converting. So if we want to convert decimal degrees, this is like 38 degrees, 12 minutes, 5 seconds. It's like, what does that even mean? But to convert that to something like just degrees, it just means it's a decimal, and people, I don't know if they got lazy or like were really creative and they were like, how do we not write a decimal? Let's just write this as, you know, as one like weird looking thing. So to convert this to just a decimal degree, right? We always keep the 38. So 38 degrees, I mean, that's in degrees, we're good to go. The minutes and seconds, that's going to give us a decimal, and we figure out what it is based on these conversions in this chart, and then we say, okay, like there's the decimal added on to the 38. So let's start with the 12 feet here. So 12 feet, or oh my god, feet. I'm gonna keep saying feet because minute, it's minute, but okay, you're with me, right? Sort of. And remember, one minute is like this. So 12 minutes is going to be, to convert it to degrees, we're going to use this conversion right here. We're going to multiply it by 1/60th of a degree, which this just means 12 minutes over 60 degrees. And I don't know where to write the degree in this case. I don't really know. There's no wrong answer really, but this is going to be 0.2 degrees, right? And if you don't have a calculator on hand, I mean, we're all virtual, so use your phone, use your computer, use whatever you have. But calculators are like allowed or useful in this class, right? I'm pretty sure. I have another class where they're not allowed, but check the syllabus and then you can we can talk about it Thursday because I'll check too. But yeah, you can definitely use them in class, and I'm just wondering on exams. I can't remember, but I think you can use them on exams as well. Okay.
I have a question.
Oh yeah.
Uh, I just don't understand. Are these units of measurement particular to to this problem,
Yeah.
or
So uh, there is a
because it
there.
just I don't understand the
Yeah.
minutes, seconds.
It's very weird, but it's yeah. Okay. Thank you, Michelle. She said it's like the circle is a clock. So think of it like the minute seconds is where the angle. It's like a part of like if you go 1 minute, that's point or well, okay, if you go 12 minutes, it's 0.2 degrees.
So it takes a cockroach 60 minutes to go 1 degree.
We're not onto the cockroach yet. Is
Oh,
that so
okay,
we haven't talked about that yet. That'll come later. But
okay.
for the cockroach, like in order to go, we don't know anything about the time that's happening, but if the cockroach goes, 1 degree, yeah, I guess this is what this is saying. 1 degree is 60 minutes. But I mean, this is a weird.
Yeah, I just don't understand.
I see what you're saying. I see what you're saying.
It's not like time, though, is it? It's not.
No, that 1 degree is not about time, right? Like 1 degree, it's saying because 1 minute is 1/60th. Like I guess you can think of it like on a clock, but it's not actually talking about time. Like I'm not saying, or at least that's not how I'm understanding it. So
Okay.
I would just worry about the conversion and don't think about like a problem just yet. And when we get to one, if we get to one that is like that, hopefully it's clear for all of us. And then David, you have a question?
Yeah, just real quick. That 38, that's not part of the equation, right? That's technically
No,
just
not
stands
yet.
for 38.2, or are we doing
No, yeah.
something
So
with
so at
38?
the end, okay, so at the end we will add up the 38 degrees, whatever we get for degrees here and whatever we get for degrees here, we'll add all them up and it'll be like 38.25 or something, right? Like and that will be the degree decimal.
Okay, so if a, if a degree is next to that weird combination of numbers, that we add them together. We don't multiply them.
Yes, we add them. Yes. Yes.
Okay.
Yeah. Okay, so let's finish. So we found the 12 feet. Now let's find the five. Oh my God, I'm gonna keep saying feet. The 12 minute. Now we find the 5 seconds. So 5 and this double tick mark. Keep in mind, like this conversion here, because this is the double tick mark is our second, and so we have 5 seconds here, which I want to figure out how many degrees that is. And so to do that, I'm going to use this 1/3600, and I'll just divide 5 by 3600. Now, okay, we should approximate because it's like some really long decimal, and we'll say it's 0.0014 degrees. And maybe it's better if I don't write the word and I write the little note or the little circle. So now what I have is I have 38, then I have 0.2, then I have 0.0014. So to get my decimal degree, the final answer, I'll just do 38 plus 0.2 plus 0.0014, and this is going to be 38.2001. Oh no, 2014, right? My bad. How nice that I can just go backwards. Okay.
Is there
So
a way
this-
you can
oh, yeah.
explain the like the I guess the formula or what you're using to plug in? Because
Oh, I'm using,
that portion is kind of confusing for me because it says 1 minute equals 60 seconds, but 1 degree equals to 3600 versus the 1/3600 degrees. I know you're trying to convert it into the decimal degrees, but both
Yeah,
have.
so-
So how do you differentiate?
So these on the left hand side are maybe not as useful. Maybe we should only because the way that they get when it says or, the way they get that is they just divide both sides by like they just divided both sides by 60 or by 3600, right? And so what we're actually using for in this case is this conversion, like the one on the right, and then we're using this conversion, the one on the right also, but underneath. Are you seeing that? Is that making sense? So we're ignoring the first part, because if we were given if we were given it the opposite way, which is in the next question, we're going to be using these two and using larger numbers to convert. And you'll see that in the next number 3. So we are only using, for number 2, we are only using these two conversions right here. Okay, it's okay. Does that make sense? We're only converting minute to degree and second to degree. So Alice, I don't know. The 1 degree equals 60 minutes. That wouldn't help us convert minutes to degrees. We'd have to divide both sides by 60.
Do we round the decimals?
And you can round. If you rounded different than me, that's okay. But I went pretty far, I guess. If you just said point like 001 and you left the rest, or maybe you rounded it up, but that's fine. Unless it explicitly asks you, but in this case it doesn't, right?
Okay, got it.
I just don't want to get this confused. Is this leading up to radians? Is that kind of what we're doing there?
Yes. So
Okay.
eventually, like I said, this is a bit silly, I think, but I mean, I have to follow the curriculum, right?
It's just like teaching conversions kind of thing?
because you're
Okay.
never really going to use this. You guys are really only going to, like, after this section, probably, you might see 1 or 2 questions, like multiple choice or something on the test that's like, convert this. But I might even give you these conversion, like this, this chart, like these numbers right here, because it's just not that important. It's more important you know how to convert. And when we get to radians and degrees, that's really the very important conversion, right?
Okay.
Yeah. Yeah, that's a good question. Okay, and I actually have to fix one thing. Is there a way I can freeze this? Probably not. Bear with me, because I'm going to just go to my settings real quick, if I can figure this out, and say pencil. Oh, shoot. I can't. Does anyone remember how to, like, not let me draw with my finger? There's, like, a setting that you can do for that. I can figure it out for next class, but display? No.
Disabling the touch.
Yeah, I think you just had to go back to the Apple Pencil.
Oh, it's in here. Okay. Oh, here we go. No drawing with finger. Oh, thank you. All right. Thanks, all you tech people. Okay. Or just like more savvy than me, right? Okay. Okay. So let's do this next one, and then hopefully let's kind of move on from this weird degree, minutes, seconds. Because then when we get to radians, it'll be, well, I think radians are nice, but it's nicer than this, I guess. So if we want to convert, they're saying this DMS is degree minutes seconds from 120.48 degrees to something that looks more like this in the previous problem, right? Like 100, it'll be 120 degrees, and then the 0.48 represents some sort of minutes and seconds, okay? And so let's take a look at that. So I know right off the bat, I'm not going to do anything with this 120, because I know my final answer is going to have 120 degrees, and that's not going to change. You can see my dog's wrestling behind me if you're looking at the camera. So let's hope they don't. Okay. Yep. They're going to eat each other. So it's fine. So now what we want to do is take this 0.48, and we'll take the whole 0.48 just to start. And it's degrees. And we want to convert this. So we have degree, and we want to first just convert it to minutes, right? So to do that, I'm looking specifically at this degree. 1 degree is 60 minutes. So if I multiply by 60, I now have minutes from degrees. So I'm going to multiply by 60. and I'm gonna get, because if I have 0.48 degrees, then I get, or 60, I should have written minutes. And like technically you could divide by 1 and it's like 60 minutes over 1 degree, right? That's where this is coming from. The degrees cancel each other out. You're left with just minutes as your, like, maybe that was better if I put all of the cancellations there. So now like degrees cancel and we have, what do we get? 28.8, 1 tick mark, because that's minutes. So now I have 28.8 minutes. So it's 28 minutes and then 0.8 of a minute. So we'll convert that to seconds. Okay. So now, so I know in my answer, I can take this 28 and I can say 120 degrees, 28 minutes. And now let's find that last piece. Let's find the seconds. Okay. So to do that, we pull this 0.8. So I have 0.8 minutes. And I want to look minutes to seconds. Now I'm looking at this guy. 1 minute is 60 seconds. Well, okay, we do know that. Or that's something more common, right, than degrees to minutes. So 60 seconds are in 1 minute, or maybe I'll do the little tick mark. And sorry, I'm writing out seconds, but maybe I should have done the double dashes. But so now 0.8 times 60 gets me 48. If I ever do math wrong, oh my God, please just holler, because, yeah. Okay, so this gets me 48 seconds. So I can add this here, 48 seconds, and this is my final answer. So in degrees, minutes, seconds, it's 120 degrees, 28 minutes, and 48 seconds is equivalent to 120.48. Oh, geez. Okay. Hey. Yeah, we hear you. You're loud. Okay. All right. So now we get into radians, which, I mean, I think we could have just started there, but like, I think it was William that said, so you're totally right. They're like trying to prepare us to convert, which is cool, but, you know, could have just hopped into it, I guess. Right. Okay.
On that last problem, you're converting the just whatever's after the decimal.
Yes, we're only converting what's after the decimal. Yeah. Yeah. Oh, and somebody said, okay, so somebody asked me in the chat, sorry, I'm just seeing it. Shouldn't we do 60 times 60? Well, technically we did. So I see what you're saying, but if you look at this, so technically we took this and we multiplied by 60, right? But then we took what's left over of that, multiplied by 60 again. That's why we only had to do by 60 once. If we went straight from 0.48 to seconds, we would have done 60 times 60, which is 3,600, right? And someone said minutes and seconds are always less than 1 degree. Oh yes, they're the decimal. They're the decimal point of a degree. Like they're what's after the decimal. Yeah, I think.
Right. Yeah.
Okay.
That's what I was asking. Yeah. Thanks.
Okay, cool. And if seconds come out to a decimal, what do we do? Or will it never do that? Okay, it will never do that for you guys, but if it did, you'd be going into like milliseconds, and we're just not. You would just keep multiplying by 60, really. But we're that's too much, and we're not going there, right? So if it ever happens, either you calculated something a little bit off, maybe you forgot like when you were putting it in your calculator, or the problem is totally wrong. And you know what? You can just write me a note and say, this isn't right, and I'll give you the points. but yeah, so that should be fine. Okay. So now we want to say, we want to look at these questions. So number 4, how many radians are in 1 full revolution? So now we're looking again. We have our initial side here. We're going to look at a unit circle, I think, is what or just a circle. But we have our initial side. We have like a potential angle side. We have like our angle theta is here. You can see that theta is 1 radian. So what they're showing us here, this specific theta is equal to 1 radian. They just measured that out for us. We never have to know exactly like what 1 radian is, but then we can see that the radius is also equal to the arc length, which is s. And they explain that right here, right? Length length of the arc denoted by S equals the radius. Okay, so then if we were to split this up, I'm gonna attempt 1 radian. So no, Tristan's saying 1 radian is 60 degrees. No, 1 radian is like slightly, it's a decimal, and it involves pi. So it's a decimal that's just repeating a lot. But we can calculate that exactly. But I'm just for now we'll just stick to like 1 radian, and this theta is just a theta. It's nothing to do with degrees.
Oh, okay.
I may have to kick them out of the room, but just if the dogs are bothering anyone,
Supposedly
message me in the
7:45.
chat and just say
What time
kick
is
them
it?
out. Okay, so I'm gonna put
7:45.
little tick marks. Like I'm gonna estimate. So like if this is 1 radian, maybe 2 would be here,
I'm good.
maybe 3 would be there.
Hot pocket.
And I'm estimating this, but I also know. But just to show you guys, 4, 5, 6, and then like a little extra. I don't know. So I'm showing you if like this is 1 radian. Maybe this is a second one. We have a third. We're trying to figure out how much 1 full circle, like how many radians. So by eyeballing it and just estimating, we can kind of try to guess like what. Oh, I've used like all the colors, but okay. And then there's this like little chunk left. So it's about, so how many radians are in 1 full revolution? Well, it seems like I'm going to write, it's exactly like 6.28. Yeah, thank you, Michael. But so we can write 6.28, or we can see from the picture, Kobe. We can see from the picture slightly more than 6, right? Which exactly, it's like 6.28. But also, this is equal to, so the full circle
How many radians are in 1 full
of-
revolution?
of like the arc length is 2 pi r, right? Where r is the radius. So for the unit circle, which is what I was talking about really, the radius is 1, so it's 2 pi, right? So this is for this specifically, this answer is for the unit circle when r equals 1, right? And 6.28, this equals 2 pi. But if we wanted to write it exactly. So that's what we have here. And we can see that just based on kind of what we graphed there. And you can also note that in radians, if you want to write this in, this just for now, I mean, we're going to look at this more closely, but it starts at 0. 0 radians equals 0 degrees. Right? Then we have pi over 2 is 90, pi, 3 pi over 2, and 2 pi. And that's just, just for your reference there. And this will help us with number 5. Sorry, there's a question, David. Are radians the same or different for every problem? Well, 1 radian is always the same thing. Okay, I need to kick my dogs out. I'm so sorry. Give me a moment, everyone. I'm going to yell at them.
Poor dogs.
On that first one, did she put like pi over 2? Trying to.
Oh, yes. Okay, so on the top there, it's pi over 2. My handwriting is crap.
Got it.
Okay. Okay, so who said what was going on? Sorry, I sent my dogs away. They should be gone for the rest of class. Are radians the same or different for every problem? So 1 radian is always the same. Oh, there's the cat. Okay, I see it. I'm figuring out how to see everything sort of at once. So 1 radian always represents the same thing, but in each problem, they're going to be different, right? Like the answer will be different. Like it's not always going to be, it's 1 radian or it's, but radians are always the same. Kind of like 1 degree is always like 90 degrees is always a right angle. But like 1 radian is always a radian. I don't know. I don't know if that really helps, and then half circle is pi. Yeah, half a circle is pi because a full circle is 2 pi, right? So, that's why Tristan showed the cat. Michelle, I didn't realize Michelle typed that. Okay. All right. So let's keep going. So now we want to draw these angles, and standard position just means start from the positive x-axis. So when it says draw them in standard position, that's all that means. But we will start with 5 pi over 6. So again, I'll label like 0, this is pi over 2. And it kind of always helps me to just label like all of the angles there. I don't know, it just helps. You don't need to, but it's a good habit maybe. And then for this first problem, pi over 2, it might also help to think of this as 3 pi over 6 and this as 6 pi over 6. Because then you want 5 pi over 6. Well, hey, I mean, that's like almost 6 pi over 6, but it's more than 3 pi over 6, right? So you could kind of guesstimate really well that might be 5 pi over 6, right? Something like that. And again, if yours might look actually better than mine, but as long as it's in this general area, this is 5 pi over 6, I would give credit. Like if you put it in a different quadrant, okay, that's a problem, obviously. Or if you put it like, right there, like that's too close to pi over 2. So as long as it's in that general area. Now let's look, so hopefully that was clear. Now let's look at negative pi over 3. So again, it might help to say, okay, 0 is the same. This would be, this would be negative pi over 2. Then we'd have negative pi here, and I won't continue that. But it might help to say, okay, negative pi over 2 and negative pi over 3, that's going to be, so negative pi over 3 is going to be somewhere in between 0 and negative pi over 2, right? So I'm going to just kind of guesstimate and say, okay, it's like a third, it's a third of pi. So if you think of that whole bottom piece, kind of try to break it up into thirds, but maybe a third is like there, I don't know, from, here, and here is negative pi over 3. Again, it just should be somewhere between 0 and negative pi over 2, right? Okay, so we're finally getting to this roach on the fan business. And again, I don't know what's going on. Oh yeah, and Jakob said 150 degrees. Yeah, so if you converted that, and if that's easier, you could always convert radians to degrees, but sometimes it might ask to then keep your answer in radians. Just keep that in mind. But if you're like, no, I'm a degree person, like all the way, convert to degrees all the time. That's totally fine. Gets you really good at converting. But okay, we are finally at this nasty roach on the fan, and it says, how far does the roach travel riding stationary on the fan blade in 1/4 turn at 1 centimeter from the center? This is just weird, but let me draw it and then it will make sense. And they could have just asked for this angle. Like it's just bizarre, right? But okay, so we have our fan, and they're saying the fan, oh, maybe I'll undo that. They're saying it's 1 centimeter from the center. So the center is here. They're saying this is 1 centimeter. So they're saying the radius is 1, wherever the cockroach is. And I can't draw a cockroach, but here's a nasty, I don't know, maybe that's more of a spider, okay? So it's 1 centimeter, and they're saying a 1/4 turn, yeah, just ridiculous, a 1/4 turn, right? Which just means think of a full circle or a full revolution, right? It's the 1/4, so that brings me here, and it's saying how far does it travel? Well, I'm thinking in radians, so this is 0, this is pi over 2. So the angle that it travels is pi over 2, or 90 degrees for all of you who are like, yeah, we like the degrees better. So how far, oh wait, so it's the answer is pi over 2, sorry. I was reading some chats, but I'll get to that in a moment. But so you could have also said, like, okay, so another way to think of this, the answer is pi over 2, right? He travels pi over 2 radians. That's how far. But because that's the same as our arc length here. But what you could think, if you didn't want to think of it this way, So if the cockroach completes a quarter of the full circle, this means the first full circle is 2 pi times 1, right? So 2 pi divided by 4, because that's a quarter, and this equals pi over 2. This is just another way to get what we just got. I was thinking of it in terms of 1 full circle, quarter, right? But now, if the radius wasn't 1, if it was, r, then there would have to be an r here, and there'd be an r there, whatever that r was. I'm going to get rid of that, but I just wanted that to be clear. We are almost always going to work in the unit circle, but if not, it's going to be very clear, and you'll just remember to put that r in the equation. Michael says, get your road spray. Yeah, I have like 10 bottles on hand, right? Because we're in Texas, and I'm not from Texas. So when I saw my first one, I was like, what is this? Like,
get used to it.
Yeah, I'm used to it now. Now I smash those things. I've been teaching before. I saw one run under my couch. This was like when COVID first hit. So we were all virtual. Literally saw one under my couch. I said to my class, I'm like, just give me like 2 minutes. I stopped. I moved my whole furniture in my house. I killed it. And I was like, all right, now I can teach. Like, I couldn't have taught with, welcome to Texas.
Yeah, it's kind of gross.
Totally. But they were all like typing in the chat, get it? Yeah, kill it. Like, this one. And then
so could the fan turn the other way? I mean, does it?
So yes. So we are assuming, if it's not said, we are going to assume counterclockwise, because normal route. However, it does not say here. So they were just saying, how far does the road travel? It could be pi over 2, but it could have been negative pi over 2. It could have been pi over 2 at some weird, not starting from a perfect right axis, but I was just drawing that picture for you, right? So yeah. Good question. And then someone else just said, will these notes be on Blackboard? My iPad is not working. Yeah. So these notes, I will post them to Blackboard, along with I will post the shorter versions so that you guys can open up what we're doing. So yes, these will definitely be in Blackboard. It may take me a day or a few hours or something. I have like 2 other jobs. So, we're doing that, putting in the work here, trying to pay the bills. So yeah, so just bear with me there, but I will absolutely get these on Blackboard. Okay, so now we want to look at converting. This is the chunky. This is the good stuff. Converting between degree and radian. This is what it all comes down to, and this is what's really important. You will have to memorize this. I mean, I will not give you this. Granted, you could like have it on a Post-it note somewhere, and I wouldn't know. But I didn't say that, except this is recorded. So. But yeah, so degrees to radians multiplied by pi over 180, radians to degrees multiplied by 180 over pi. So really, usually pi cancels if you're going to degrees unless you have decimals. So it's pretty obvious, like, hey, cancel out the pi and just multiply by 180, or vice versa. You need pi in your answer. So it usually is a little bit obvious, but I shouldn't say it always is, because sometimes I even get mixed up. So we see here, we want to convert degrees to radians, these first 2. So we're going to take the 85 degrees and then pi over 180, right? Because I'm doing the first 2. Oh, I should have maybe done green here to match up here, but degrees to radians, right? And this will end up being, so you can do this however you want. I'm not judging. I'm not, it's fine. But I like to cancel, like, okay, I can divide these both, I think, by 5 and get 17 here and 36 here. You could do this in your calculator, hit reduce and hit enter. I mean, whatever floats your boat. You could write 85 pi over 180 and then reduce it. But I just like to do kind of as little work as possible. And you do want to reduce this eventually. So this will be 17 pi over 36 radians, right? Don't forget that radians, because we're not in degrees anymore. So don't write that little degree symbol. So notice, something that somebody pointed out to me once, degree symbol is here, degree symbol, right? And then notice here, no degree symbol. I know that might seem like so obvious right now, but just like when you're in the zone or you're not thinking, sometimes people just write the degree symbol or they forget it. And you want to keep track of this, right? You want to just make sure we're on the same page. So negative 220, I'm going to again do pi over 180. Oh, this is harder to reduce in my head, but it's 22 over 18. So I think it's just 11. This is negative 11, and then this is 9. Yeah, okay, not so bad. So this is going to equal negative 11 pi over 9 radians. And now we want to convert radians to degrees. So again, that's going to be this guy. So I have 5 pi over 6. I do 180 over pi. The best thing about this is these pi's will literally always cancel, right? And sorry, people are typing in the chat. Yes, 85 degrees, you got it. And somebody did ask, can we convert radians to degrees, seconds, minutes, or degrees, minutes, seconds, right? DMS. We definitely can. I mean, I don't know if you're asking you want to do this in class or can we do this? Like, just is it possible? And yes, it's possible. Just for time purposes, I might not do this right now, but if we have time at the end, we could come back and do it if you really wanted. But yeah, so just let me know what you meant if you want more. And then 150 degrees. Oh yeah, you already got it. Perfect. So this is going to be, we can simplify the, well, and I just write what it simplifies to. You do not need to do this, but I'm just doing this so people know, like, how the heck did you get this? Well, this is how. And this is 150 degrees. And yeah, DMS, yeah, okay. So the person was just asking if we could. I mean, yeah, sure you could, but in our purposes, why, right? Why would we want to? But you definitely could. Okay, so then the next one, and feel free to, like, I'm loving this. People are typing answers in the chat and stuff. This is great. Feel free to keep doing that if your heart desires. And we got negative 60. Excellent, because this goes to be 1, this goes to be 60. And
really quick, I have a question. So for 8A, where did the 5 go, and how'd you get 30?
Okay. So yeah, so this is why I like to write what I did write. So the 6. So what happened here was I had 5. The pi's canceled, right? I had 5 times 180 over 6. And okay. I simplified this first, and it's 30, and then 30 times 5 is 150.
Makes sense. Thank you.
Yeah. And that, like, again, I get excited sometimes, and, you know, Jakob, you're excited too, which is great. Or you're at least putting answers in the chat. And so, you know, if that does go too fast or somebody misses something and you have that question, so Victoria, that was great. You know, feel free to ask. We're all here to help.
I have a question.
Yeah,
so
Michael.
I read that in that section that radians has no units, but so is it okay to write radians?
Okay, yes. Yeah, so I think in the book or wherever, yeah, technically, and so I'm already messing this up, but technically you do not need to write radians, and that's the whole point of the whole degree. So if you left off the degree, like this technically is the right answer, right, for this problem, because it's radians. Okay. But if you left off the degree in this one, it would look like negative 60 radians, and that's like, what is that? We don't do that. You know, I mean, that's a lot of revolutions, or that's a weird angle to be looking at, but yeah. So that is a good call. I just like to write radians because for me, but I will maybe try to get better, and so
it's okay if we write it or don't.
It's okay if you write it, and it's okay if you don't. Yeah.
Okay.
Cool. Yeah, that's a good question. As long as you're understanding what it is. I mean, that's what's important, which is why I like to write it, but it's totally not necessary. Okay. So yeah, good call. Okay, so now we're going to look at arc length, which is that S, which is typically just the angle, or I mean, it's typically just the radius. But when we get into some more fun things or non-unit circle things, it's maybe like there's this simple equation, right? So we have here, let's see, we have a circle of radius r, length s is the length of the arc, we have the angle in radians. So this equation, the most important thing to note here is for this equation, your angle must be in radians. So those of you that love degrees, I'm so sorry, but you're gonna have to get radians just for this, right? So let's just note that for all of us. So the reason this works is because like 2 pi r, that's a full circle, right? 2 pi r. But then if I multiply this by, in order to get my arc length, you can actually, oh yeah, somebody just said their calculator converts for you. That's a nice calculator. I did not have that growing up, so lucky you. You can actually divide this by the full revolution, like to get the radius, but then if you multiply it by the angle, this is gonna give you, this is like how we get the equation. This gives you the arc length, but not less important. You really just need to know S equals R theta. This is really important. And you need to note that this is in radians, right? So that's what's important to note here, and we can cancel with that. Okay. And this is like finding a sector of this, right? So that's what we're looking for. So 9, back to that cockroach, because for whatever reason, we're not leaving it. How far does it travel on the fan blade from tracing an angle of 5 pi over 6 at 20 centimeters from the center? So that's a long fan, or no, 20 centimeters isn't long. It's just moved from the fan. So we have 20 centimeters from the center. So if I sketch my little, and again, I'm starting perfectly from the positive x-axis just because it's easier for me, but you do not need to do this. You could start really from wherever the fan is, right? So let's say this is our roach, or maybe I wanted to just draw this, and then this is 20 centimeters, and our little guy is here, and he's moving fast. And he's gonna go 5 pi over 6. We did this earlier, right? So I know it's like somewhere here. This is 5 pi over, not over 2, over 6 radians. And that's our theta. And the roach is moving on the fan that much, right? He's traveling. So it's saying how far, so that would be S, like the arc length. And maybe I should do that in a different color so we can see. So here's our little roach, and how far does he travel? So we go back to our equation, S equals R theta, right? And this 5 pi over 6 is our theta, right? And our R is 20. So kind of makes it easy for us, right? 20 times 5 pi over 6. We can reduce that, or you could multiply it and then reduce, or let your calculator do all the work, however you want to do this. But 20 divided by 6 reduces to 10 over 3. And then we have 50 pi over 3. And remember, this is centimeters because 20 was in centimeters. But that's the exact answer. So this is exact, right? But in this case, to me, like 50 pi over 3, like usually we want the exact answer. That's perfect, right? That really is, I mean, truly perfect. But in this case, if I wanted to get more of it, like 50 pi over 3, I have no idea in centimeters what that actually is, thinking about it. So you could, and it doesn't really ask, but you could get the decimal answer. So let's just write the decimal answer would be, you would just do 50 times pi divided by 3, and it's about 52 point, you could say 0.4 or 0.36 centimeters. So these are the same things, right? If it asked you, like in ALEKS, like I think it was maybe Michael who was pointing this out earlier, ALEKS can be super finicky. And if it asks you for a decimal or the exact answer, you need to make sure you're giving it what they're asking and you're not rounding till the very end, because they could, like you might have rounded sooner or something and you get 52.35 and it was 0.36, like how annoying, and you get it wrong. So that can be really frustrating, and you can always email me. I'm here for you for that. But again, like I'm with you that it's frustrating, but just try to be aware of that. And calculators are great. I mean, from what Tristan's been saying, calculators nowadays, they're great, right? So let them do all that work for you. Okay, so number 10, now we've got something going on here. Key West, Florida. Well, it would probably be less hot there now than it is in Texas, but maybe not. It's located at this like northwest coordinate, right? 24.1 degrees north, 81.8 degrees west. Cleveland, Ohio is here, 41.5 north, 81.7 west. Since the longitudes are nearly the same, so they're 0.1 off. So they're just saying longitudes are the same, consider them to be the same. So I'm gonna, because of that, I'm gonna kind of like circle these and like cross this out. Circle these and cross this out. Because longitudes are nearly the same. The cities are roughly due north-south of each other. So what they're saying is they're roughly just like north-south is up and down, right? So they're roughly above each other or below, depending on where you're starting. So using the difference in latitude, we're going to approximate the difference between cities, assuming the radius of the Earth is 3,960 miles, round to the nearest mile. Okay. And when we do word problems, I'm always going to like highlight or underline or circle, because I think that helps. Sometimes things are not important later or more important. Oh, I see another cat. But, you know, you can determine that and do what you want with it. But I just think it is important when you read this. So what we're looking at here, I mean, if you looked, well, you could look on this globe, you could like literally, I think they wanted you to, you know, like pick a point and be like, okay, like we're really close. Like there's our coordinates, and like it's almost north south. Well, I missed Florida, but you get the picture. But I'm not going to draw it on the globe. I think that picture is just there for your knowledge. I'm going to write it out here where it's just nice for me. And again, I start on the positive x-axis, and I say my radius is 3,960 miles. My angle, well, so I have two angles here, right? I have 41.5 degrees north and 24.1. I'm starting with the bigger one because I know I have to kind of, well, you really could just stack them both, right? Maybe I have done this kind of poorly, but we'll see. So I want to kind of combine these angles and figure out my bigger angle is my 41.5 degrees north, and I'm starting on the positive x-axis and drawing it north. If this was south, I mean, we could do a similar thing. But so there's my theta there, 41.5. Then I want this here. This is my 24.1 degrees north. And I have my radius. So ultimately what I want to do is figure out what is the difference here between these two angles, and then convert this or use this with my S equals R theta, because I want, I want to find, like we already go up here, and I want to find the difference. I want to find, sorry, let me pick my color. So this, I should have done this. This whole thing is the 41.5. And part of it is 24.1, right? So this should be like this. This should be like this. I want to just find this piece, the difference between the two. And this is like my S. And I'm going to use S equals R theta. But to do that, I wrote theta for each of these. That's probably confusing. And that was too much. How do I get it to be too? There we go. Okay, now I have to fix this. But okay, hopefully, so this is just my 41. I'm not going to write theta in there so that it doesn't confuse you. But the theta I am looking for is the green. So we'll do this, right? There's our theta. So maybe that's a little better. And someone already calculated. They looks like they possibly got it. I don't know. Let's see. So you'll want to find for theta, you'll do 41.5 minus 24.1, and you should get 17.4. And these are all degrees. I should be writing the little degree mark. And the reason for this is because now remember, this needs to be in radians. So convert to radians. And then you can just plug it in and plug and chug and just get your answer there, right? So you'd have 17.4 degrees times pi over 180, which you could leave this as a as it is, or I wrote it as a decimal and wrote like 0.303 6 something or 7, I don't know, something like that. You could even just leave it in your calculator, but I'm just writing it out for myself too. And then I get S is going to be the 3960 times 0.3037 ish, right? And you should get, actually, if you entered the exact one, which I think you'd get exactly what Jakob got it. It's 12,003 or 1,203 miles. I actually didn't check if that's accurate, but you could probably Google it on a map and see, is Key West really that far from Cleveland, Ohio? I'd be curious to know.
Okay.
Okay, so now we're talking about coterminal angles. So this is just terminology that I'll show you what this means. But like, for example, the angle that's drawn here, this blue, like that's one angle, right? It's probably less than 90, it's maybe 60 or 45 degrees or something, right? 50 degrees. Now, let's say you wanted to go around and then end at the same spot. You would just add one full turn. So you'd add, 360 degrees, right? It's like if you can jump and do a 180 or a 360, if you do an extra spin, you just add 360 to it, right? You just keep adding. Or if you wanted to go the opposite direction, the negative way, you could do this. And no matter what you did, you end up in the same place, right? You end up in the exact same place. So even though these are all different numbers or angles, they look different. Like one might be 50, then it might be negative 130, and then it might be, that'd be like negative 290 or something. But they look different, but they all get you to that same place. It's kind of like if you spin left or spin right, but if you spin the same amount, you might be facing the same direction in the end. So here, what we do to get these are called coterminal angles. And to get these, we add or subtract multiples of 360 degrees, or 2 pi radians, right? If we're in radians. And I'd say to get the coterminal angle. So, man, we're back to this roach. I don't know when it ends, but maybe on the next, this whole section, the roach just continues. So it says, when the roach has completed 3 revolutions plus an additional 45 degrees, what is the measure of the angle it's completed? So, and then it asks, what position is it in first revolution? Okay. So what this is saying is, it's traveled 3 full revolutions. One revolution is a full circle. Revolution is 360 degrees, right? So we're going to have 3 revolutions. So 3 times 360 degrees plus an additional 45 degrees. That's going to be how the measure of the angle it's completed. So that's 1,125 degrees. And what is this equivalent to? Well, in order to figure that out, it says what is it equivalent to in the first? That means in the first revolution. So between 0 and 360. Well, to figure that out, you would just it's really large, right? So subtract 360, subtract 360, subtract 3. You would just subtract 360 until you get to a number between 0 and 360. So it probably takes like 2 or 3, two subtractions or something. And I think you get, maybe I'll just do this. 1125 minus 360 minus 360. I think that's 45, right? No, it's minus one more. Right?
Mm-hmm.
Oh, actually, that's so silly. Because we did 3 revolutions here, I should know that it should just get us back to 45. That was, I mean, okay. If I didn't have that first, but so you would just subtract these and you're going to get 45. But this, because we're adding 360, just that's it, 360, this is equivalent to 45 degrees. It's not, the roach is not traveling maybe as far of a distance, but 45 degrees is an equivalent angle. It's a coterminal angle for 1,125 degrees, which sounds kind of insane, but that's how angles work because you're just spinning in circles, right? You're not, driving away or anything like this. So now these next 2 questions are not about the roach necessarily. They just ask, let's figure out in the first revolution, so between 0 and 0 and 2 pi, because now we're in radians, what is coterminal to 17 pi over 3? So again, this is too big. We want to subtract. So we want to subtract 2 pi until we get something between 0 and 2 pi. We might only have to do it once, actually, I think, right? 17 pi over 3 minus 2 pi. This is the same thing as 17 pi over 3 minus 6 pi over 3. I like to make the denominators the same. Again, your calculator, if you ignore the pi, or even if you don't, I guess, your calculator will do this for you. And yeah, you get, Jakob's right, you get 5 pi over 3. Which is our coterminal angle. And if this was negative, then you would just add, you would keep adding if you wanted to get between 0 and 2 pi. If it was negative 17 pi over 3, you would add and add, right? Okay, so this next one, not that it's tricky, but it wants you to find a positive and a negative coterminal angle. It's giving you no specifications, just one that's positive, one that's negative. So what this tells me is I can take 75 degrees, add 360, here's a coterminal angle, that should be positive. Then I can take 75 degrees, subtract 360, and there's a coterminal angle that's negative, right? So you should get, I think the positive is 435, not 25, yeah. And then the negative one should be negative 285. So here's your 2, these are coterminal angles to 75 degrees, and one is positive and one is negative. You could have added again or subtracted again and given me a different answer, and you're still right because it didn't ask in any range, right? So you could have done that.
Can I just point out that on number 12,
Yeah.
you have to subtract 6 pi over 3 2 times to get 5 pi over 3. Right?
Oh, geez, did I messed it up?
I
You're
was
right.
wondering about that.
Oh my God, thank you so much, because I even have that in my solutions and I was losing my mind. So we need to subtract 2 pi and we get, because you only get 11 pi over 3 here, right? Yeah. Then you want to subtract it again. Okay, there we go.
Right.
That's right,
Right.
except, yeah, I kind of, it's not nice the way that it's written, but you're right. So maybe what I'll do actually, just for those people that'll look at these later and be like, what happened? I'll just write this. Okay. That's a little better. Thank you so much, Michael, because I wasn't even going to notice that that was true. Okay.
So that's 2 pi's over 3?
Yeah, so we subtracted 4 pi over 3 because we subtracted, we subtracted 4 pi. We subtracted 2 pi and then 2 pi again.
Okay.
And the reason we did it is because like this answer here, this is still too big. And so we need to subtract again to get, because our answer had to be between here.
I see. Okay.
Yeah, that was my bad. But in this one, in number 13, they don't care where they are. They just say a negative and a positive doesn't matter. So it doesn't have to be because like 75 is already between 0 and 360, so they probably didn't care.
I'm sorry, can you kind of explain that portion? Because you have the 6 pi, you have 11 pi minus 6 pi, and then it equals to 5 pi?
Yeah, because 11.
Okay,
Yeah. Do you want me to explain that one more time?
just briefly, yes, please.
Yeah. So here we have, so first, I mean, we want to subtract 2 pi, right? Because this number is too big, and 2 pi is 1 full revolution. So, and 2 pi equals, let me back that up. 2 pi equals 6 pi over 3, and it's easier for me just to subtract when it's like that, right? So 17 pi over 3 minus 6 pi over 3 got us this 11 pi over 3. But our answer had to be between here, and 11 pi over 3 is still too big because it's bigger than 2 pi, which is 6 pi over 3. So if we subtract again, it gets us enough. It's kind of like we're going backwards. So if you're looking at like this, 17 pi over 3 is like, like, oh, well, okay, this is bad. But it's like something like this. And we needed to go backwards. We needed to take away this one and then take away this one and this is not a good drawing, but we needed to subtract 2 full revolutions in order to get just the little piece left that we wanted.
Which would be that like 5 pi over 3?
Which would be the 5 pi over 3, exactly.
Okay.
Yeah. And that picture is not accurate to 5 pi over 3, but I just was trying to describe it in a picture. Yeah. Okay, and class, so we do have like 1 minute left. So for today, I don't wanna like rush anything. So this last page I'll finish at the beginning of next class, and we should still be able to stay on track, and I'll do 5.2. But I will make sure in Blackboard that I upload this. Or maybe I'll wait till I'm totally finished, or I don't know if people care. But I'll upload each of these sections separately so that for those of you that if it's too big or takes a long time to scroll, you can just have each section individually. And if you like the whole bundle, you can download all the Unit 1 notes and just have them all at once. So I will do that. And please, upload your, I don't know when I made it due, I should know in Blackboard, but upload your answers to those questions for me so I can read them and read about you guys. And I really should, one day, maybe I'll even kind of go through each of your names and make sure I'm saying it right, or make sure, at some point. But, today's question. Let me send it out. Let's do today's question is just going to be any pets. The notes will be posted. I can post them tonight for those of you that are asking for them, like to work on the homework or anything. So today, I know some of you already told me what pets you have, but if you have pets, type it in the chat. If you don't, just say no pets, that's okay. But I will make the next question more interesting for you guys. And I will, and you are all set to go unless you have questions. I'll stick around a few minutes, but I will see you Thursday at 6 o'clock. Thank you.
How do we type?
In the chat, if you select the chat, you should be able to type. Can you see if you go to Zoom, can you see the chat? Oh, maybe I'll stop sharing. Maybe how do I do that? Oh, geez. Okay. Let's see. Stop sharing. Yeah. Maybe that was better if I stopped sharing.
Oh, yes, I see it. Thank you.
Yeah, no problem.
Have a good evening. Goodbye.
Yeah, have a good night, guys. I will post these notes, give me 20 minutes after class, and I'll try to upload everything.
Next class. I have a question about the prerequisites.
Yes.
Yeah.
So my school was in Canada, and it's going to take too long for them to send me stuff by Friday. So if I want
it can be unofficial. It can be unofficial. Do you have that?
Yes, I do. Yes.
Okay, so if you have unofficial documentation of it, just email. Do you want that email again? Lorlando at austincc.edu. So email her with your ACC ID, my name, and then your unofficial transcript attached, and just say this is for the prerequisite, and you should be good.
Okay.
Thank you.
Yeah, and she'll check in with me Friday, and if she hasn't heard from you, she'll tell me like a list of people, and I'll just like reach out to you again and be like, "Hey, can you send that real quick?" But yeah, because otherwise, I would wait till Monday. You'll probably wait till Monday if like for me to actually check and like students to be withdrawn, but it would happen probably by Monday.
Okay. Yeah, I just sent it, so hopefully there's
Oh,
no
you're
more
good. You're good
issue.
then.
Yeah.
Yeah, you're good.
How do you check on because I ended up taking a test on I guess Alex, and it was kind of lengthy but not so much. Is
Okay.
that what you're talking about that they need, like, or is that something completely different?
So maybe like you can either submit a transcript if you've taken courses somewhere else, or you can submit the Alex placement test. I don't know what the placement test is because this is my first time teaching pre-calc with ACC, so I'm not familiar with the prerequisite things. So that email that I sent, if you just want to email her and say, like, her name is Lindsay Orlando, and just say, "Hi, here's my ACC ID. I'm in Kelly Maluccio's pre-calc," and you can say, I took the Alex placement. Is this correct? Like, actually, wait, Alice, did I say your name at the beginning?
Yeah, no, I was the last one. I go by Alice.
Oh, Bertha. Okay, Bertha. Okay, okay. I was like, I don't think I said your name, but I did. Okay. You
But I
took
took,
ACC.
I took stuff from I took finite math, like two of them, and then I took the 20. Sorry, I think it was like 14, 13, and then I took some other stuff. So I've taken a whole bunch of math.
Okay. Yeah, I just I'm not really sure what's required of like what the prereqs really are. So if you just email her, if you're covered, she'll correct it. And whoever typed for the prereq, Jakob, you're all set. You don't need your status was good. And if anyone else where does the textbook come into play? The textbook should be linked, and it's where your homework assignments are. So like Alex, the problems that they assign, I'm like 90% sure they come directly from the textbook. It's connected. They're linked. So that's kind of where it comes into play. I don't know, because this is virtual. I mean, you have access to like an e-textbook too, and our guided notes are like, in addition to the textbook, I guess, the notes that I will post on Blackboard. But yeah, you don't need, unless you want it, like a physical copy of the book. Up to you, right? But.
So is the first day assignments due today? Like the first day that...
Yeah, so I think I'm like, let me double check when I made it due.
Okay. Is there anything due today?
No, I don't think so.
Okay.
But so if you go to Blackboard and you go to submit assignments here, first day info, let me click on it and see. I made it due next week. So
okay.
You have, and it's probably because if people add drop this week, I made it due next Wednesday by midnight. So I'll remind you on Thursday, I'll remind you again next Tuesday, and then it's due Wednesday, right? So you have plenty of time.
Okay, perfect.
Yeah.
And then just by commenting, that we were in class.
Well, yeah. I mean, it
Okay.
also takes, and for you, like, it takes your attendance. Like, it tells me all the people that are in. So if it's your name, like for you, your name says iPhone right now. Was it iPhone the whole time?
No, I was on my iPad, but my iPad is under my mom's name.
Oh, okay. You can
And
change
so-
your name though. Do you know how to do that? Or maybe only I can.
I don't know how to do that, but I don't know. I think I'm going to be using my phone because I'm able to screen record on my
Okay.
phone.
Okay.
So yeah, I don't know.
That's totally fine. That's totally fine.
Okay.
As long as, well, and if for you, if you wanted to, when you answer the questions, if you want to also just dash like your name, because I don't,
Okay.
you know what I mean? Because otherwise
Yeah.
I see my phone or I see your mom. If it's your mom's name, I could probably figure it out. But
Okay.
just to know that it's you.
Okay.
Yeah.
Okay, sounds good. So will my chat be okay for today?
Yeah. For today, you're
Okay.
good. Thank you.
Okay, I'll do that further. Thank you so much, Professor.
Yeah,
I
thanks.
appreciate it.
Yeah. Have a good night.
You too. Bye.
Any other questions?
This kind of for like the whole
Okay,
class.
thank you.
Is anybody interested in doing like a study group?
Oh, okay.
I really need.
Somebody messaged. Was there a group me?
Yeah,
I don't.
that was me.
Okay, but is there one, Joseph, or no?
No, I was asking. Usually, just whenever I start these classes, somebody just posts a group me link, so I don't really know how it
I
works.
see. Okay, so I did not know this. I'm still very new, and I mean, I've taught virtually, but not this class and not at ACC. I was virtual at other universities. So let's next class. Why don't I mean, you guys can connect here. Feel free if you want, like type in the chat or whatever. But I will announce at the beginning of next class, like, hey, if someone wants to make a group me or anybody who wants to be, I don't know, study group, put your email in the chat and talk to each other or whatever. Right?
Okay.
What do you need? Like, do you just need our username to be able to do that, or it's been a while?
For the group me?
Yeah.
Oh, I have no idea. Isn't it an app on your phone? I don't know.
So I've got the app and everything. I just don't know what you would need, like just the email address, like what it's connected to the group me.
You would need, no, I don't even think, I think if someone
I think you just need a link.
Yeah.
Whoever makes it needs a link, and then they send it in the chat, and then we all click on it, and we're like, I'll join.
Yeah. So you don't even need anything ACC related for that. That's like that's on your own time, on your own thing, you know?
I think it's just a phone number. That's it.
Yeah.
I believe so.
Yeah, I think so too.
So
I want to be
really
a part of
quick-
that. Sorry.
All right. Really quick, will there be a like a place where all of the due dates are, like including like the textbook homework that we do online too? Because I saw it in the syllabus, but it wasn't like per date. This is what we're doing besides the
So in Blackboard, most of this is in Blackboard. If you go to Blackboard and you go to, I can even share my screen if I, oh shoot. Oh my gosh, I'm teaching so many classes and it's different for all the classes. So maybe this isn't true. I thought there was assignments. Okay, so in this one, they're not all in one place. Let me try to figure this out.
Sorry, I'm a paper planner.
No, I love it, but I need to figure this out because, okay.
That how much of this class will prepare us for actually like Calculus 1, Calculus 2, and all that stuff?
I mean, this class is the class that should prepare you for Calc 1. It will not prepare you for Calc 2, but yeah, or at least I don't think it will.
Okay.
But okay, so in terms of the seeing everything, I think I need to link Alex with my Blackboard or something. But so right now, if you go to Gradebook, I mean, there's only one thing in there. I'll start adding some things, but it's the first day information. But I need to link Alex because typically if you go into Gradebook, you should see all of the Alex assignments, all of the tests, like whatever. And I'll put the exams in there with their dates and it'll just have no grade until we do it. Right. I probably won't put quizzes because I don't know which weeks, like when I'll put a quiz, but when a quiz is assigned, I'll put that in there. So yeah, I'm sorry. I don't have that set up right now. But if you go into Alex, you should be able to see every assignment in Alex, and those are at least the homework. And there should be due dates. It's all set up for the semester. And then right now in Blackboard, it's just that first day info assignment.
Okay, and then for the first day info assignment, I don't know if you said it, but I have ADHD and I didn't write down. Where do we turn that in at?
Okay, in Blackboard. So I'll share my screen real quick. how can I do this? Okay. If you're on Blackboard, right? I was in Gradebook. If you go scroll down here, and if you go to submit assignments here, and then click this, and then like you would upload the file. I mean, you don't need to write comments, and then you can just submit at the bottom.
Cool. Okay. All right. Thank you.
Yeah, no problem.
Later.
Oh, I'm sorry. There's more chats. Yeah, have a good night.
You too.
So wait, where's that first day info again? Where's it located? Sorry.
Oh, it's okay. So if you're in Blackboard, right, you'll like come to the course, scroll down, hit under assignments, hit submit assignments here, and then hit first day info.
Okay, gotcha. Thank you very much.
Yeah. Yep. I don't know who's left. Okay. Oh, and Miguel, were you trying to talk? Yeah, we can't hear you. Sometimes you have to like leave and come back, or I don't know, but I wouldn't do that. But can you type in the chat? Did you type in the chat? I haven't looked. Okay. Let me look. Oh, you're just saying goodbye? Is that no? Oh, okay. All right. Thank you. Okay. Thanks. And Veronica, or oh, she's gone. Joseph, Alice, you guys good?
Oh yeah, I'm just waiting for everyone else to ask questions
yeah.
before I
Yeah,
ask.
I'm gonna head out then. I mean, I typically probably won't stay past 7:45, but we're trying to get everything set up today.
Okay, sorry. Okay, so I just wanted to ask. So was this class recorded? Because I heard you say something about recording. I don't know.
So I don't know. This Zoom isn't recorded, but my sharing of my screen is recorded on my iPad. I don't know exactly how that works because I've never used the ACC's iPad before, and I don't know if it records. I don't think it records audio. I think it just records my writing, but I'm going to post that on Blackboard anyways. So if I figure it out and if I get access to it and can share it, I will. But I do not know how that works.
Okay,
So somebody else, I don't know if it was you, but somebody else said they would just record on their computer.
That was me. Yeah, because I've been recording the entire time.
Okay, yeah, that's fine.
I have a program to record my entire screen.
Oh yeah.
Yeah. So
yeah.
Okay, cool. Alrighty. And last question. When is the assignment due?
It's not till next Wednesday. So I will remind you on Thursday and then again on Tuesday. But I'm just giving people time so that they can try to upload that.
Okay. And I am not on that list of the people you mentioned, right?
Let me double check, but I don't think so.
Joseph Garcia.
No, you are. Yep, Joseph Garcia. You are all set.
Okay, cool. All right, then that's all the questions I have. Thank you very much. I'll see you later.
Yeah, have a good night.
All right, good
Bye.
night.